Hi guys, welcome back again to Biology Tutorials. In this video, we're gonna solve another problem in thermodynamics and heat transfer, chapter 11, combined conduction and convection heat transfer, overall heat transfer coefficient. So here's our example. Consider a flat plate solar collector placed at the roof of a house. The temperatures at the inner and the outer surface of a glass cover are measured to be 28 degrees Celsius and 25 degrees Celsius respectively. The glass cover has a surface area of 2.2 square meter and a thickness of 0.6 centimeter, and thermal conductivity of 0.7 watts per meter times degrees Celsius. Heat is lost from the outer space of the cover by convection and radiation, with a convection heat transfer coefficient of 10 watts per square meter times degrees Celsius and an ambient temperature of 15 degrees Celsius. Determine the fraction of heat lost from the glass cover by radiation. So here's our diagram. So first, let us identify the givens in our problem. So we have the temperature at state 1 is equal to 28 degrees Celsius. We have the temperature at state 2 is equal to 25 degrees Celsius. And we have the surface area is equal to 2.2 square meter. We have the thickness is equal to 0.6 centimeter. We have the thermal conductivity K is equal to 0.7 watts per meter times degrees Celsius. We have the heat transfer coefficient is equal to 10 watts per square meter times degrees Celsius. We have the temperature of the surface, Ts is equal to 25 degrees Celsius, and also we have the temperature of the fluid surface from the surface, sufficient far from the surface, is equal to 15 degrees Celsius. So under steady condition, the rate heat transferred through the glass by convection is rate of heat transfer by conduction is equal to thermal conductivity times the surface area times the change in temperature over the thickness. So we have the thermal conductivity is equal to 0.7 watts per meter times degrees Celsius times the surface area is 2.2 square meter times the change in temperature. So we have 28 minus 25 degrees Celsius over the thickness is equal to 0.006 meter. So cancel the square meter, the meter, the degrees Celsius, and the unit is the watts. So our rate of heat transfer by conduction is equal to 770 watts. Next, the rate of the heat transfer from the glass by convection is, so rate of heat transfer by convection is equal to the convection heat transfer coefficient times the surface area times the change in temperature. So we have the heat transfer coefficient is equal to 10 watts per square meter times degrees Celsius times 2.2 square meter times the change in temperature. We have the temperature of surface equal to 25 minus the temperature of the coefficient far from the surface is 15 degrees Celsius. So our rate of heat transfer by convection is equal to 220 watts. Cancel. And then next, under the steady condition, the heat transfer through the cover by conduction should be transferred from the other surface by convection and radiation. That is, rate of heat transfer by radiation is equal to heat transfer by conduction minus heat transfer by convection. So let's plug in. So our rate of heat transfer by conduction is equal to 770 minus the rate of heat transfer by convection, that is equal to 220 watts. So the answer, 𝐶𝐸 is equal to 550 watts. Then the fraction of the heat transfer by the radiation becomes fraction of heat transfer is equal to rate of heat transfer by radiation over rate of heat transfer by conduction is equal to 550 over 770, that is equal to 0.714 times 100, that is equal to, let's cancel, so that is equal to 71.4%. So this is our answer.